right, we're going to do on page 241, number 16. So if you're at home or in class, then you can see how this one's done. This one's probably one of the hardest ones that we're going to look at. So there's that. And so let me go ahead and start this one. And so I'm going to leave out a step because I don't think we need these steps. I have another recording that has all the steps in it, but for your purposes, I think we are going to leave out one of the steps and just keep it in geometry, no algebra. I'm going to have to take this sign down, but while I'm talking, I'm drawing my little shape here. Yeah, I'm going to take it down. But like while I'm drawing, I was just going to, talk over it. And I know it bothers you. There we go. All right, so anyways, so I'm going to draw the shape, but I'm going to draw the shape separated. And so I guess I should show you what the shape looks like before I draw it. Okay, that's what the shape looks like before I draw it. But I'm going to separate it up. I'm going to break it up because it might make it easier to see. And so that's... And we'll do that. Because the problem is this particular one, and I'm going to mark it up like it is on the thing. Okay. And I think I'm zoomed in, so we'll unzoom so we can see all the glory of the purple problem. All right. So the problem is in the given, I'm going to write that down in a second, is they give us that this part of this line equals this part of this line, this part of this line equals this part of this line. Okay. So I'm going to just go ahead and write down, it looked like, when I first saw this the first time, I like, what's the point? I think they give you all the sides you need, but they don't give you all the sides you need. So you got to be careful what it is. I'm just going to show you how that is. All right, I think I put the right sides on it. That's all I'm given. And I'm going to put my little plan over here. My plan is side, 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 because they didn't give me any angles. And I don't see any shared angles on the shape, so I'm going to think side, side, side. Later on, we're going to kind of look at different shapes and come up with the strategy for them before we actually mix our proofs. But that's fine. So we're going to do the easy one first. So I'm going to get, well, the easy one is this side's already given, right? It's one side. I'm going to do the easy one, which is WV. It's congruent to WV, and that is reflexive, right? Hopefully we are getting to see that a lot, where if the triangles touch, they share this line, WV, it's going to be reflexive. So now I've got two sides. Now I don't have to get one side. Well, and I'm going to say technically what we need to do, but we're not going to do it for this class. I don't think it's constructive. Technically what we would need to do this next level is switch things back into algebra and then switch things back into geometry. But we're just going to leave it in geometry, and so we're going to do it. We're going to be okay. All right, so what I'd actually need to do at this level is I don't want just this line. I don't want just this line. I want the whole line, right? And so I'm going to add those lines together. So I'm going to add up, let's see here. Let's call this Vy plus Yx equals Vx. Okay, does that make sense? I guess I could have labeled this. Like it was in the book. That kind of helps. Okay. So I just made this whole line right there. Okay. I'm going to say WZ equals well, WZ is going to equal what? I didn't put this point. This point is Y. This point is Y. WZ is going to equal WY
plus YZ.
Plus YZ. What allows me to do that?
Couldn't tell you.
What did I just add? Line segments, right? So back in the day, back several chapters, we had the segment addition, because we're adding segments, and the names are so creative. I left out letters. Postulate, because I'm paying attention to other things. Okay, the segment addition postulate allows you to add that. Okay, that is in your toolbox. This might be on the test. I'm just not going to make you change it into the equal sign, even though you're supposed to do it. So I'm going to leave it. I'm going to basically leave it in congruency sign, because I think that's how we're going to do it this year. So we're going to just say the segment addition postulate works here. I think that'll make our lives easier. I'm going to leave up the other video if you want to see another way to do it. Segment addition postulate, so I just added those together. Okay, now I want to make, ultimately I want to make Vy equal to WZ, right? And then I'm done with my side. So probably what I can do is this. WZ equals, well, let's not do WZ. Let's do WY plus YX equals, I'm sorry, let's call that YZ. WY plus YZ equals VX. Now I need you to figure out why that's true. What did I do to this line right here? What did I do to this line? How could I possibly get WY instead of VY? What property allows me to do that? Remember substitution? Okay, because up here, let me see, does Vy equal Wy? It does, doesn't it? Okay, I told you this one was hard. Okay, how about Yz? Is Yz and Yx the same? Okay, so this is a substitution property. Okay, now I'm going to make the statement WZ is equal to, or congruent to, because I didn't switch it, is equal to WZ is equal to VX. What property allows me to do that? Okay. What? So PQ, QR, PR. What property is that? You got to go back to the algebra stuff. What would that be? Starts with a T. There it is. Okay. So the transitive property. And so then the last step, I got my SSS. So the last step is triangle. I told you this one was really hard. Okay. Triangle VWX is congruent to triangle WVZ. Side, side, side. Now, what I'm going to tell you, I don't want to totally confuse you. What I'm going to tell you is what I omitted from this is technically here and technically here. You need an extra step, but we don't have to do it. But you need an extra step that basically is a definition of congruency. Definition of congruency. What that does is change your geometry into algebra, lets you do algebra work, and then change it back into geometry. Don't worry about that. We don't really have time to do that aspect of proofs. So just this would be what you need to know. Okay? So segment addition postulate is handy when you have broken up segments, and you can add them together, and this is kind of the process of turning two broken up segments into equal segments. Okay. If this is the only thing that is hard to you, then you are in really, really good shape. There's a good chance that, well, I'm not going to say it online, so bye.